Hi everyone, and welcome at today's webinar from construction schedule to analysis, where we will take a detailed look at our construction schedule, how the tasks are interpreted by the program for the calculation, and at the end we will go together through the results. My name is Blaž Mulavec, and as a technical consultant, I am a part of Bridge team at the Competence Center Alpine Infrastructure here in Graz. Today's webinar will be a little bit different because we will not deal with how different functions can be used and how is the correct input, but rather with the understanding of what is happening in the background and how the program works. For this purpose, I have chosen our getting started example, which you all have and already probably know very well. It is a bridge based on a real project, and I have loaded the model directly by clicking in our Backstage library on the symbol and recalculated the model. To give a brief overview, the bridge consists of two piers and a main girder. The bridge is slightly curved, therefore it also has a crossfall. The cross section is a hollow box cross section with two sets of tendons for pre-stressing, and the bridge is equipped also with asphalt coating, two sidewalks and concrete barriers on each side, which are defined as superimposed dead load and represented by the green color. The bridge is supported by the two soil supports under the piers and the two abutments, one at the end and one at the beginning. So this is how our geometrical model is defined, and our analytical model is derived automatically out of it when we choose Create Analysis Model in the calculation options. Now let's have a look at our construction schedule. Our construction schedule is divided into 13 phases, of which the first 5 are construction phases representing our permanent load. In the following 5 phases are defined different loads. The next 2 are used for superposition and combinations, and the last phase is used for design and checks. These last 8 phases we could also define all in one, but to have a clear overview, we have defined for each load a specific phase. Each phase is assigned to a specific time period on the time axis and then further divided into different tasks. In the construction phases, for each task, a specific start day or date can be defined, and the duration and the end day is calculated out of this automatically. For the phases for loads and design checks are set to final, meaning we will load the structure, evaluate the superposition and combinations and perform design checks at the end when the construction is already finished and the entire bridge is already in service. Of course, if needed, this could be also done differently by simply defining a start day, for example, for settlement load, and then move it up in the hierarchy of the phases. So first, we have defined new construction schedule. We can define many different variants. And in the first 5 phases are defined according to the planned construction timeline and activities on the construction site. In the first phase, the 2 piers are built and the soil supports are activated. In the second phase, the first span of the main girder is concreted, the first abutment is activated, and the first group of tendons is pre-stressed. In the third phase, the second span is concreted and the second group of tendons is pre-stressed. In the fourth phase, the last span of main girder is finished, the second abutment is activated, and the last group of tendons is pre-stressed. In the fifth phase, the bridge equipment is installed, and so the superimposed dead loads are activated. This way, we have mapped the overall activities of the construction process at different points of time, which is nicely represented here in the Gantt diagram. And we can also visualize our construction process. But this is not all. When the model is transferred to Allplan Engineering, we have then 2 models available for further use. The first one is our entire bridge, and the other one is where the model is divided into parts in the same way as we have defined our construction phases. So the main girder will be divided into 3 different parts. This step-by-step construction process, which we have defined, also affects the state of stress of the entire structure during the construction as well as after its completion. Therefore, the construction process must be considered also for the analysis. This is why the focus of today's webinar is to show you and demonstrate how the product derives construction schedule calculation from these definitions, and we will focus only on permanent loads. To make it better understandable, I will skip now some phases for the calculation, and afterwards we will slowly build our bridge phase by phase, and in parallel we will also look into the logging to see how the program interprets for specific tasks. Here in the action bar under calculation, we have a possibility to activate, for example, timeline for our constructions, to create analysis model, auto-generated tasks, and to calculate structural analysis. And here, if we click on the small arrow, the calculation options window opens with 3 different tabs. The first step is for the analysis. If we have defined different construction schedules, we have a possibility to select the desired one and to either turn it on or off for the calculation. Further below, we can see the list of auto-generated calculation tasks like self-weight, superimposed dead loads, for pre-stressing, for creep and shrinkage, and for the total summation. We have a possibility to define our own name if desired for the partial load case as well as for the summation load cases. And for the creep and shrinkage calculation, we have additionally possibility to also define the duration of infinite creep, in our case 100 years, and the number of logarithmic time steps. We will use, in this example, 7 logarithmic time steps. If we are not interested in intermediate load case results, we can also delete them automatically for the calculation. In the second tab, the superposition, we see listed displacements and forces, and we also have a possibility to define additional leading components, like, for example, stress points. Under the third tab, Advanced, we can determine our desired tolerances for creep and shrinkage and choose if the shear deformation according to Timoshenko beam theory should be considered or not. So for the beginning, I have skipped also some automatically generated calculation tasks. And now let's continue with our construction schedule. So in our 4 construction phases, we have used the tasks concrete, inst, sup, and tension. If we move our mouse to a specific task, for example, and press F1, then the help window will open automatically. And here we can see listed all our construction tasks with descriptions, and we can also see which automatically generated tasks are initialized by these construction tasks. So our first task is concrete. This is actually a container task of 2 tasks, pour and harden, which could be used also separately. Concrete construction task initializes following 3 automatically generated calculation tasks: the inst conc, which stands for concrete installation, and this task activates our structural members, our elements. The next task is LC self, which is for self-weight calculation. And the third one is LC creep, which is for the creep and shrinkage calculation. Our next task used is the inst sub, which activates our springs, in our case the two abutments and the two soil supports, and this task also resets the load cases for self-weight calculation and for grip and shrinkage calculation. And the third task used is tension, which is also a container of 4 tasks: inst duct for the installation of ducts, inst tend for installation of tendons, T-stress for the pre-stressing of the tendons, and T-grout to grout the tendons. This tension task activates then the 3 calculation tasks: T-stress, which evaluates our tendon stressing, LC stress, which calculates our pre-stressing load case, and T-grout, which establishes the bond between the tendons and the cross section. Now let's recalculate our model and see how the program has interpreted our first construction tab. Here at the bottom left, we have our logging window, which we can also pin, so it is visible all the time. In the logging window, we have a possibility to filter our messages. For example, now we have received some warning messages telling us that in our analysis model we have used some elements which are not yet activated in the construction schedule. So by that the main girder is meant, and therefore we can ignore these messages. We can also export our messages as a CSV file or as a text file. Then we have 4 different columns. In the first one is the level of the information shown, either debug, info, warning, or error message. Then the next one is for the time. Then the third one for the code number, and in the last one is the written message or the written information. So after we recalculate our model, first the calculator is loaded, and then, similar to our project structure, are also the elements calculated. First the axis, then the different cross sections, then our structural members, the 2 piers, then lancets and load trains for traffic loads, then earthquake, tendon groups. Because we have a variable height of our hollow box cross section, we have many different variants, and all the variants are then calculated. And then we have already reached our interpreter for the construction schedule. As you can see, on day 1, load case for self-weight summation is set, and on the 21st day our 2 piers are finished, and so is also are also our 2 piers activated. Here we can exactly see for which elements this is thought. We can see that the elements from 1201 in step 1 all the way up to 1204 are being activated. The same for the second pier and for the 2 soil supports. After the piers and the soil supports are activated, self-weight for the two piers is calculated. We can also see again the two elements shown. And afterwards, the partial result of self-weight is summed up in the summation load case. Now, let's see in the results. So, we have different possibilities to represent our results, either as 3D diagrams, where we can check our deformed structure or present different diagrams for displacements and forces. And we can check our results also as tables, which can be also exported in Excel format. And the results are then for displacements, internal forces, stresses, tendon forces, and design checks. Here at the bottom, we have results data, and we can switch between load cases, different envelopes, lens aids, design checks, and eigenmodes. Today, we will go through the load cases results. So, on day 1, we see here the number in the bracket. It's number 1. This means this represents our day argument from the defined construction schedule. And this way we know exactly which results we are looking for. So on day 1 we have empty results because on day 1 the load cases results have been set, and our first construction phase is finished on day 21, where we can see the results for this phase. Now I will activate also the next phases. And let's see again what has changed in the logging. So for the first phase, nothing has changed. And on 49th day, we see that the first span of the bridge of the main girder is concreted. Then the first abutment is activated, and the self-weight for the first span is calculated. After that, the partial result is then summed up again into the total sum for the self-weight. On day 78, the second span is activated, and the self-weight for this part is again calculated and summed up again. And on day 107, we see the third span being activated, the second abutment, and again the self-weight was calculated for this part and summed up again. Now I will also activate the calculation of superimposed dead loads and pre-stressing, and let's see what has changed now. Now we already at the beginning we can see that the two activated load additionally activated load cases for pre-stressing and superimposed dead loads are set on that day 1. Then in the first phase, nothing has changed, but in the second phase, where we concrete the first span, we can see again the activation, the self-weight calculation, and here we can now see the 3 tasks which are initialized by the construction task tension. We can see exactly for which group of tendons the pre-stressing is being evaluated, then for which group of tendons is also the load case calculated, and the bond between the tendons and the cross-section established. Similar to self-weight, also here the partial result for pre-tensioning is then summed up into the summation load case. Similar, we can see also in the second span or in the third phase that we have again actions for tension, and then the same also for the last span on the 107th day, and on 127th day we can see that the load case for superimposed dead loads was opened, and then the loads for unit load 2, unit load 3, 4, 5, and 6 are calculated. This comes from our unit load definitions for these parts, and we can see that the unit load 2 stands for the roadway, 3 for the right sidewalk, 4 for the right barrier, 5 for the left sidewalk, and 6 for the left barrier. We can also see here that mass is true, meaning that in our definition we have chosen that the derived, automatically calculated or derived masses from these parts should be taken into consideration also for our earthquake calculation. At the end, we see then that the load case closes, and again the partial results are summed up again. Now let's check again our results. We can also copy our diagrams, and now let's go through the results. So on day 21 we have our 2 piers being calculated, and on day 49 we can see the partial result for the first span of the main girder, as well as the partial results for the pre-tensioning. Then we have the summation results for self-weight, as well as for pre-tensioning. Here we can see the second span results, partial results for the second span, and the summed up results. The same also for pre-stressing and self-weight for the third span, where the self-weight is then summed up again. And on day 127 our bridge equipment was installed, so we can see also these results. Now I will activate for the calculation also creep and shrinkage and the total summation load case. Now let's have a look again in our logging. Now you can see again that on day 1 also creep and shrinkage load case was set. Then at the beginning of the first phase nothing has changed. We have again the activation of the structure members, activation of the supports, calculation of the self weight. But then we see here on day 21 until day 49, creep and shrinkage for the first phase is calculated. Then the partial results are again summed up in the creep and shrinkage summation load case and in the total sum. On 49th day, we have again the activation of the first span, of the first abutment. The partial total summation result is copied. The self weight is calculated, added to the summation for the self weight and for the total sum. Then our tendons are pre-stressed, load case calculated and the bond established. And again, we see creep and shrinkage calculated from the 49th day all the way up to the 78th day. The same or similar happens also in the third phase, where again creep and shrinkage is calculated from 78th day all the way up to 107th day, when our last span is activated and our entire analytical model or statical system changes again, and therefore the calculation for creep and shrinkage is resetted. And on 127th day, we see the superimposed dead loads being placed, and after that we have again the creep and shrinkage calculation. And here we can see the 7 logarithmic steps for creep and shrinkage calculation for infinite creep, which we have defined here in the calculation options. And after that we have reached our final stage, where again our partial results are summed up in the summation load cases. Now I will check again the results, and again we can see all the partial results for specific days. Then here we can already see the results for the logarithmic time steps for creep and shrinkage, and at the end, at our final stage, our final results. Now I will activate also the rest of the phases, and after recalculation we will see how the program has interpreted our entire construction schedule with all the construction tasks, as well as all the loads and evaluations of superposition, as well as design checks at the end. If you have pinned your logging window, you can all the time see exactly what is being calculated. So now, at the beginning of, or in our first 4-5 construction phases, nothing much has changed. But after the calculation of 7 logarithmic time steps for creep and shrinkage, when we have reached our final stage, we can see that with LC open, the settlement load case is being calculated. Then afterwards is the temperature calculated, then braking, wind, then the earthquake, then our envelopes from the superposition are evaluated, and combination tables as well, with all the traffic loads. Then the linear stress is being calculated. And at the end, our code design and design checks are performed. If we take, again, look at our results, we can see at the beginning, again, all the empty load cases being set, then all the partial load cases, and here at the end, after we reach our final stage, we can see the results for braking, for creep and shrinkage total results, then for the temperature, pre-tensioning, total summation load case results, self-weight total summation, as well as settlement and wind results. So with all these calculation tasks being listed in the calculation tasks list, and all the calculation tasks being listed in the calculation tasks list, we can define our construction schedule for our bridge construction. As you could see, everything has a very simple logic, although the mathematics and physics behind in the calculator are everything else but simple. In order to do our best to best simulate the norms properly on one side and to make it simple enough for bridge engineer on the other side to be able to have a deeper insight in what exactly, or on which time point exactly, and how the program is calculating and analyzing his designed bridge, so he can feel sure and secure about his definitions and free and flexible enough, knowing he's not working with a closed black box. So with this, we have reached the end of my explanation part, and now I will check if we have some questions. Yes. So if I understood correctly, with all the calculation and construction tasks, we are able to set the complete analysis calculation also by ourselves, and the auto-generated calculation tasks could be switched off. Is this correct? Yes, this is correct. As mentioned, you can either use automatically generated calculation tasks, or you can skip them and use the tasks from our two task list. The first one are our construction tasks list, and the next one are our calculation tasks list. The next question: are the results listed chronologically? Yes, the results are listed chronologically. As mentioned before, the numbers in the brackets are representing our day argument, which we have defined in our construction schedule, and this way we know exactly which results we are looking at, and those results at the end are results from the final stage, so to say, the final results. Therefore, there are no numbers in the brackets. So yes, results are listed chronologically. The next question: in the third phase, the construction is finished on 78th day, while creep and shrinkage for this phase is calculated until 107th day, when the fourth phase is already finished, and not until 94th day, when the fourth phase begins. Yes. So regarding creep and shrinkage calculation, we calculate creep and shrinkage from the time point where our elements are activated and all the way up to the next time point where our statical system changes by the activation of the further elements in our system. So the creep and shrinkage is calculated from 21st day, for example, for the first phase, all the way up to the 49th day, when the first span of the bridge is activated and our system changes, and then we calculate again creep and shrinkage from the 49th day all the way up to the 78th day, when our system changes again. So, are there any further questions? No? Okay, we hope that with this webinar we could give you a deeper insight in how bridge functions, and that now you will be able to use bridge even more powerfully. I wish to thank you for your attention and wish you pleasant working with bridge and a lot of beautiful bridges. Thank you and goodbye.